Hey everyone, welcome to our last example problem that we're going to run through, hopefully to get you ready just to try out the last sheet and into the end of the unit. So some ammonium nitrate is stirred into 2.50 times 10 to the 2 mils of water, and the temperature drops from 22.7 degrees Celsius down to 10.1. The molar enthalpy of solution for ammonium nitrate is found out to be 57.3 kilojoules per mole, and then this is asking what mass of ammonium nitrate must have been added in. So in this case, we actually have something new. We don't have something that's burned. We don't have a state change that's happening. We have a solution. And so that's another type of reaction that can happen. But it's the same equation. It just gives a different x value for our delta Hx equals NHx equation. So we should always start all of these questions by saying what's being gained and what's being lost. So I always start these problems and say, okay, energy gained by what is equal to energy lost by what. And in this case, the energies being gained must be by the solution, because when I look at the temperature for the water, it drops from 22.7 down to 10.1. So the energy is being lost by the water. That must mean the energy is being gained by the solution. So adding in ammonium nitrate into water is causing this to drop down. And so the solution is a reaction that's happening. And so reactions, we normally say we have delta H, and in this case we have solution that's there. Now, energy is being lost, that gives me a negative MC delta T, because that's due to a temperature change. So if I start to plug in my values from there, okay, and really I guess I could put in and just say this is negative Q, right, because it's energy. And then in my next step I could plug this in. So we'd have NH solution is equal to negative MC water. Delta T. So if I have my values here to solve for, it looks like the only thing really different here is the N and the M, keeping in mind that N right now realistically would be in moles, and then I have an M value that I have to solve for. And it does tell me that I have 250 mils of water, so we have to use those conversion tools that we've had before. If I have 250 mils, that's the same thing as saying 250 grams. So let's start left to right and fill in what we have here. So my amount, I don't know what this is right off, because that's what the question is asking for. What mass of NH4NO3 must have been added in? So I don't know what N is right off. But I do know that my solution, it does tell me, is 57.3 kilojoules per mole. So 57.3 kilojoules per mole is a molar enthalpy. That's absorbing energy in this case. And that's going to be equal to the mass value that we have, which is, I keep my negative out front, is 250 grams, which was, remember, 2.50 times 10 to the 2 mils. And so 1 mil is equal to 1 gram when we talk about water. The specific heat capacity, 4.18 joules per gram degree Celsius. And my delta T value, final minus initial, is 10.1 degrees Celsius, subtract 22.7 degrees Celsius. So my N value that I don't know, 57.3 kilojoules per mole, is equal to, and then I have some things on the right hand side that I can kind of multiply and figure out. My grams are going to cancel. My degrees Celsius is going to cancel once I do that subtraction. And then let's just kind of see what we end up with here. So negative 250, we'll keep the units in for now until we actually multiply everything together. 4.18 joules per gram degree Celsius. And then what I'm noticing when I subtract here is I'm getting negative 12.6. degrees Celsius. So my negative values are going to cancel out when we multiply together. My degrees Celsius is going to cancel out, and my grams are going to cancel out. So really I'm just left in joules on the right hand side. And so when I multiply this together, 57.3 kilojoules per mole, really what I'm getting is 13,167 joules. And so, same thing from the last one that we worked on in the previous video. Because we have kilojoules per mole here, I'm just going to convert this into kilojoules now. Take my 13,167 and divide it by 1,000. So I get 13.167 kilojoules. And then when I divide this through over to the other side, right, divide the 57.3, because I want to solve for n, over to the other side, 57.3 kilojoules per mole. My kilojoules are going to cancel, and I'm going to have an n value that's left in moles. So when I divide this out, we end up getting that n is equal to 0.22979. And that's moles. And then keep in mind of what we had for an equation here. We had ammonium nitrate, NH4NO3. And so now I have moles. I need to convert this into grams to finish this step off. And we've been practicing a little bit of going from moles to mass, so hopefully we're just able to kind of keep our steps going. 22979 moles of NH4NO3. Multiply that by, and I need my molar mass. So for every 1 mole, and I'm going to have moles on the bottom here because I want to cancel it out, 1 mole of NH4NO3, and then I have the molar mass on the top. So I need to go to the periodic table, and I need to add up 2 nitrogens, 4 hydrogens, and 3 oxygens, and come up with a total. And when I do that, it looks like I get 80.06 grams of NH4NO3. So moles of NH4NO3, moles of NH4NO3, and then they cancel out, and I can see when I multiply this that I get 18.3969, 874 if I kept track of all of my digits, grams of NH4NO3. So now the last step would just be, let's figure out how many significant digits we have. So if I go back, significant digits, to take a look, I have 3 here all the way through to the other side. We have 2.50 times 10 to the 2, so all 3 digits here would count. Same thing with the specific heat capacity, and when I subtract terms, each one is to the 10th place, so that's going to go to the 10th place here. So then when I have 3 in each one on that right hand side of the equal sign, I'm going to end up with 3 digits that are going to count moving forward here. 3 digits divided by 3 digits, so 3 digits are going to move forward. And when I divide by one that has 4, or multiply, sorry, I guess, by one that has 4, remember we always take the value with the fewest. So 0.229 only has 3, 80.06 has 4, which means I'm going to end up with 3 in my answer, and this thing's going to be 18.4 grams. So keeping track, at the very end, 18.4 grams of NH4NO3. So that tells me the amount that I would need of ammonium nitrate to bring water from 22.7 degrees down to 10.1 degrees Celsius. So we've built up a little bit of a toolkit over the last several videos and last couple of sections, and you're ready now for the last kind of problem set that goes along with this section, which then leads into a unit test for thermochem. And so good luck, and let me know if you have any questions.